Hi everyone, let's take a look at quadratic puzzle number 4. So the first thing that you can notice is that you're given that a pattern q of t is equal to t plus 2 and t minus 2 in parentheses. What you might notice is that the a value isn't obvious because there isn't an x squared term, but the a value is always going to be the number that's on the very left side of the equation outside the parentheses. So since there's no number there, we know that the a value is secretly 1. Also, this should be familiar to your quadratic algebra unit about a month ago, and this is factored form of a quadratic, so it actually gives you those two zeros. So you have a 0 at t equals -2 and a 0 at t equals +2. So if we go to do the graph, those are probably the easiest points to graph at x equals +2, t equals +2, and at t equals -2. So then we can see that our vertex is going to happen right in the middle of those two things because parabolas are symmetrical. So the vertex must happen at 0. So what I can do next is go into my table and start to figure this out. So I'm going to put 0 right in the middle because that's where my axis of symmetry is, right in the middle of my two zeros. And then -1, -2, -3, 1, 2, 3. And then I have to do a little work, so I can put 0 here and 0 here, but I have to do a little work to get this y value. So I'm going to come up here and substitute 0 in for t, so I have 0 plus 2 and 0 minus 2. So I have +2 multiplied by -2, and that will give me -4, and that's my vertex. So now I could either use our shortcut of over 1, up 1, over 2, up 4, over 3, up 9, over 1, up 1, over 2, up 4, over 3, up 9, or I could do the math. So I could substitute 1 into this equation. 1 plus 2 is 3. 1 minus 2 is -1. So then I would get -3. 1 times -3. Going into my key features, slope not relevant, a value is equal to 1, and this is concave up. Our x-intercepts are given to us in the original equation. Our y-intercept we found in our table. When x is equal to 0, y is equal to -4. Since it's a parabola, it goes all the way left and all the way right. There's no x that will blow this up. So x can be anything. X exists in all real numbers. We know that our vertex happens at 0, -4. Therefore, our range are the y values above -4, above our vertex. And our axis of symmetry, since that runs through, is at x equals 0. Reading function notation, you're given an x value of 8. 8 plus 2, 10. 8 minus 2, 6. 10 times 6 is 60. And that should be positive 60. Positive 60. Recording.
Oh, sorry.
Lily says hi.
Hi.
Reading this left to right, so I'm going to start over here on the left-hand side and follow our line, and it is moving down, so that's when the rate of change is less than 0. This is where it is neither moving up nor down, so that's where the rate of change is equal to 0. And this is where the graph is moving up if I move left to right, so that's where we're increasing, that's when the rate of change is greater than 0. The only thing that happened here, it didn't get flipped upside down. Our a value is still 1. It did not get shifted left or right. It just got shifted, the vertex got shifted down 4, -4. So that's the only thing that we should have checked there. Last but not least, we have careful algebra. When does our pattern hit 4? So here, we're going to have to get this equal to 0 since it's a quadratic puzzle. So we're going to use our double rainbows, or you could use the box method to expand this. And I get t times t is t squared, 2 times t is 2t, -2 times t is -2t, and 2 times -2 is -4. And that becomes t squared minus 4. Set it equal to 0. Actually, since I only have one variable, I can use PEMDAS backwards. So I'm going to add 4 to both sides. So I have 8 equals t squared. And then I'm going to take the square root of 8. Remember, when I take the square root, I have both positive and negative values. Using what we know from November of this year, you could break up the square root of 8 into the square root of 4 and the square root of 2. The square root of 4 is 2, and then you're left with the square root of 2, which is equal to what we would get on